We will continue towards the identity structure. So the topic is Galois field. So Galois is a scientist, and in cryptography we will use only the finite groups, finite fields, or the finite rings. We will not talk about the infinite number of elements, because in that case my key search or the encryption and decryption algorithm will not work. That's why in the crypto we talk about only the finite fields. So in crypto we will ring that I already discussed in my previous lecture. So now we talk about what is Galois field. So Galois is a scientist name, and Galois scientist that for a field to be finite, because we are talking about the finite field now. So for a field to be finite, there is one condition. It has to sustain. What is that condition? The number of elements in the finite field should be in term of p to the power n. The number of elements in the finite field should be p to the power n. Here p is the prime number and n is the positive integer. And this type of field is known as Galois field. So how do we represent our Galois field? Galois G and field F, and in the brackets, because it denotes the number of elements, my number of elements should be p to the power n. So p to the power n. This is the representation of the Galois field. So that finite field is called the Galois field. And it is denoted by GF p to the power n. Now suppose if n equal to 1, my positive integer value is n in a case. So in that one, if I put n equal to 1 in the Galois field p to the power n, GF will be represented by p to the power 1 and GFP. So in the set of residual format, we can represent it like Zn 0 to n minus 1, because it is indicated by p now. So that's why in place of Zn, we can write Zp. So Zp 0 to p minus 1. And now the Galois field supports two operations. The first one is called multiplication and the second one is addition. Supports two operations. Addition one and multiplication. Now for example, if I am using p equal to 2, p is a prime number, 2 is a prime number now. So p equal to 2 and n equal to 1. So in that case, my Galois field p to the power n will be equal to Galois field 2 to the power 1. Means it contains Z2 ranges from 0 only one element. Only two elements, that is 0 and 1. Now we have to perform the operation. The first operation is addition 1. The numbers, only two numbers are there, that is 0 and 1 and 0 and operation is add. So where addition comes place, you have to perform the XOR 1. So 0 and 0 equal to 0, 0 and 1 equal to 1, 1 and 0 equal to 1, and 1 and 1 equal to 0. So that is the addition. Addition means XOR operation. Now the second operation is multiplication. So in the multiplication one, you have to perform the same thing, but you have to calculate the multiplication in the form of AND gates. So 0 and 0 is 0, it is 0, it is 0, and it is only 1. So this type of table is called multiplication table, and the operation is multiplication means AND operation, AND binary operation. Now what about the inverses, additive inverse and the multiplicative inverse? So for the additive one, if we find out the additive inverse, and this one will calculate the multiplicative inverse. So what are the two values? The two values are 0 and 1 over there. Here the same value 0 and 1. Now we have to find out the additive inverse. So for the additive one, what will be the inverse value? That is the subtraction. So minus a will be represented in order to additive inverse. So what is the additive inverse of 0 in the set 0 and 1? It is nothing but the another value, because in the additive inverse case, whatever the value I want to find out the additive inverse, the reverse value should be belong to the same one. So 0, if we find out the additive inverse on 0, so the answer will be the another value, that is 1. And the same case, if we find out the additive inverse of 1, the answer will be 0. Now what about the multiplicative inverse? The multiplicative inverse is denoted by this one, A inverse. So multiplicative inverse of 0 means 0 inverse is nothing but infinity, right? And what about the 1? The additive inverse of 1 is nothing but itself a value, that is 1. So this is the way that you have to perform the additive operations, inverses type of things in the Galois field. Now the second example related to this one. Example is Galois field and 5 to the power 1 means prime number equal to 5, and the value of n is a positive number, that is 1. So 5 is prime or not? Yes, it is prime. So what will be my set of residual? Set of residual will be 0 to p minus 1. It indicates how many number of elements? That is 0, 1, 2, 3 and 4. Right? And that is Z5. Now perform the two operation, addition 1 and the multiplication 1. So it is very simple, just like in the previous case. This is the addition operation. So 0, 1, 2, 3 and 4. Again 0, 1, 2, 3 and 4. So 0 plus 0 and mod 5. So it may be possible that sometimes my value gets out of range. Suppose 3 plus 3 equal to 6. but my highest range is nothing but the 5 because my set of residuals is 5 only. So we have to perform the mod operation at the end. Means first we have to perform the addition one between the two values followed by the mod operation, mod 5. So 0 plus 0, mod 5 equal to 0. So the same value we have to enter over it, and the same value you have to enter over it because 0 plus 1 equal to 1, 0 plus 2 equal to 2, 0 plus 3 equal to 3, 0 plus 4 equal to 4. Now 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, and 4 plus 1 equal to 5. And 5 mod 5 equal to 0. The same case 2 plus 2 equal to 4, 2 plus 3 equal to 5 means 0 over there. Sorry, 2 plus 1 equal to 3. 2 plus 2 equal to 4. And 2 plus 3 equal to either either 0. And 2 plus 4 equal to 6 means 1. Same operation you have to perform over there. So 3 plus 1 equal to 4. 3 plus 2 equal to 5, so 0. 3 plus 3 equal to 6, so 1. So 3 plus 4 equal to 7, so 7 mod 5 equal to 2. So 4 plus 1, 5 means 0. 4 plus 2 means 1. 4 plus 3 means 2. 4 plus 4 means 8. So for that the remainder will be 3. So what is the additive identity in that case? Additive identity is nothing but the mirroring numbers. What is the number such that you can add to a particular value in such a way that you can get the same answer. So the additive identity is nothing but the 0, 1. And what about the multiplication? So 1, 2, 3, 4, 5. Sorry, not 5. So 1, where is 0? 1, 2, 3, and 4. Here the operation is multiplication. So I was writing the values directly because you know all the things how to perform the multiplication operation followed by the mod operation. So 1, 2, 3, 4. And 0, 3, 1, 4, 2. And 0, 4, 3, 2, and 1. So now the table is completed. You have to find out the additive and the multiplicative inverses. So for the additive inverse, the table is already drawn. You have to calculate it. So the values are 0, 1, 2, 3, and 4. And the multiplicative inverse 0, 1, 2, 3, and 4. Now find out the additive and the multiplicative inverse of each of the value in Z5 and give me the answer. The hint is for the additive inverse, you have to add the value of B to A in such a way that after addition and performed by the mod operation, the answer will be 0. For the multiplicative inverse, you have to multiply in such a way that after performing the mod operation, the answer will be 1. Now I'm enabling the chat. Please calculate and let me the answer know. Yes, right. The additive one answer is 0, 4, 3, 2, 1. And what about the multiplicative one, Arvind? Infinity, 1, 3, 2, 4. Good. Yes, Rekha, your answer is also right. So 0, 4, 3, 2, 1. And for the multiplicative inverse, the answer is infinity, 1, 3, 2, and 4. So the exam, the question be like, so one Galois field is given to you and you have to make the additive and the multiplicative table along with the calculation of the inverses. Now there are certain drawbacks associated with the GFP to the power n. What are that we have to see? So now the next topic is GF2 to the power n field. So actually what happens when we work with the computers, then all the positive integers in the computer are stored as a n-bit words, right? And in the byte addressable memory, all these n-bit words have to be converted into the byte format. So in the byte format, the numbers can be like 8, 16, 32, and 64 for the byte addressable memory. So that's why we have to use the integer in order to store the things in your computer. It can be ranged from 0 to 2 to the power n and minus 1. And what will be the modulus? And the modulus will be 2 to the power n, right? So if we talk about the 8 bits, then what can be ranged? 0 to 7, and the modulus will be 8. So the first drawback regarding the Galois field GF p to the power n is we have to use the set ZP, right? Where p is the largest prime number less than 2 to the power n. Tick. What is p? P is the largest prime number less than 2 to the power n. If it is the case, then it is very inefficient for our computer related memory. For example, suppose if we choose n equal to 4. If we choose n equal to 4, then what should be the range? The range will be 0 to 2 to the power n minus 1 means 2 to the power 4 minus 1. So 0 to 15. So from 0 to 15, what is the largest prime number? So the largest prime number is 13. So if we convert into GFP to the power n, if we convert it into GFP to the power n, where n equal to 1 over there and p equal to 13, then what should be the range of integers? Range of integers will start from 0 to p minus 1 means 12 under 0 to 15. So the thing is, I'm trying to say from the allowed integers from 0 to 15, if I applied the Galois field GFP to the power n concept over this, then we can only use the integers starting from 0 and finish at 12. We cannot use the integers 13, 14 and 15. That's why it is very inefficient. Second example. Suppose n equal to 8. If n equal to 8, then what will be my range? My range will be 0 to 2 to the power 8 minus 1 means कितना आएगा 0 to 2 to the power 56 means 2 to the power 255, right? So what will be the largest prime number from 0 to 255? That is 251. So if we apply the concept of Galois field GFP to the power n, then we can use only the integers from 0 to 250. We cannot utilize the numbers 251, 252, 253 and 255, 254. That's why it is very inefficient for the memory related problems, for the computer related things. So that's why the Galois suggested that instead of using p to the power n, we have to stick with gf 2 to the power n for the computer related things, which enables all of the elements under the range. So that's why in the cryptography we have to use gf2 to the power n instead of gfp to the power n. It is the first version of the Galois field. It is the updated one. That is the second one. Now if suppose n equal to 3. So gf2 to the power 3. So in the binary representation, how many number of elements are there? That is gf8. So if we talk about the binary representation, then we have required only 3 bits. Then what are the elements? 000, 001, 010, 011, 100, 101, and so on. Now, see one example over the same concept. Yes. Here we are taking gf 2 to the power n equal to 2. So we have to use 2-bit word. So what will be the possible answers? There will be gf4. So in the binary representation, we have 00, 01, 10 and 11. Now there are two operations associated with the Galois field. As you know, the first one is the addition and the second one is the multiplication. So that is the addition operation, means you have to perform the XOR, and in the multiplication you have to perform the AND operation. So as you know that the identity element will be 0, 0 and in the multiplication the identity element will be 0, 1. Now the next topic, that is the polynomials. So in the basic one, you already know about the polynomials. A coefficient value is associated with some term. So in the general view, the polynomial of degree n minus 1 is expressed in the form of a polynomial. Let me write of degree n minus 1 is expressed as this is a coefficient an minus 1 and this is a term, that is xn minus 1 plus an minus 2 and x an minus 2 and so on, and it will be finished at a1 x1 and a0 and x0. Here xi is called the ith term and ai is called coefficients. So xi is called the ith term and it is belonging to Galois field 2 to the power n. And ai is called the coefficient, and the value of the coefficient should be either 0 or either 1, because we are talking about the binary operations, as we want to store certain things in our computer. So binary representation is 0 and 1. We have associated the coefficient value stuck between two values, that is 0 and 1. So what will be the Galois field representation? Because they are only 1 bit required to represent 0 and 1, so 2 to the power 1, or as you can say, GF2. So for the polynomials, two Galois fields are associated. The first one is GF2 to the power n for the ith term and GF2 for the coefficient. So there are two fields used in the polynomials. So now example, if there is a 8-bit word, 8-bit word is represented by this one 100 and 11001. 8-bit word है जो कि मेरा ऐसे बाइनरी में रिप्रेजेंट हुआ है. Now we have to represent it in the form of polynomials. The question is, how do we represent in terms of polynomial? So it is very simple, because 1 0 0 1 1, the values of the coefficient are associated with either 1 or 0. So these are nothing but the coefficient values. So 8-bit word, what is the meaning of 8-bit word? 8-bit word means it is talking about GF2 to the power 8. Then what will be the highest degree? The highest degree should be 7, right? So what is my coefficient value? 1 0 0 1 1 0 0 and 1. Numbering 0 1 2 3 4 5 6 and 7. So you can see the highest degree is 7. So why it is 7 not 8? Because 8-bit word is representing using 0 0 0 dot 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 and highest value -1, that is 7. So in order to represent it in the terms of polynomials, what is the way? The way is very simple. Polynomial representation. This is the coefficient. Put the coefficient as it is, 1. Now multiply with the highest degree. Term with the highest degree means coefficient 1 into term, that is x, with the highest degree, that is 7. यहाँ पे मैंने term भी क्या है highest degree, ठीक है. Now the addition operation. What is the coefficient? 0, term with the degree 6. Then coefficient term with the degree 5. Then coefficient 1, term with the degree 4. Then coefficient 1, term with the degree 3. Then so on. Okay. Now the multiplication with any number will get you the answer 0 directly. So you will cancel the 0th term. Now what will be your answer? The answer will be x to the power 7, x to the power 4, x to the power 3 and x to the power 0. Now the x to the power 0 is nothing but equal to 1. So what will be your final answer? X to the power 7, x to the power 4, x to the power 3 and 1. So this is the way that you have to convert a particular 8-bit word in the form of binary using polynomials. Now question is to you. Suppose one polynomial is given to you. The polynomial is x to the power 5, x squared plus x. Now the question is you have to represent into the 8-bit binary word. Okay? How do we represent into 8-bit word? Yes, Arvind, your answer is absolutely right. Because we are talking about the 8-bit word means my highest degree is 7. So just write x to the power 7, x to the power 6, x to the power 5, x to the power 4, x to the power 3, x to the power 2, x and x to the power 0. Now identify which terms are present. So x to the power 5 is present, so the coefficient value will be 1. X to the power 2 is also present, coefficient value will be 1. And x is also present, the coefficient value will be 1. So what are the remaining coefficient value? That is 0. So what will be my final answer in terms of the binary one? So 0, 0, 1, then 0, 0, and 1, 1, 0. What is 0, 0, 1, 0, 0, 1, and 1, 0? That is your answer. Very, very simple. And the polynomials is also associated with two operation. बताने की जरूरत नहीं है, लेकिन फिर मैं बताना पड़ेगा. That is addition one, and the second one is the multiplication one. So operations on polynomials. So the first operation is addition one, and the second operation is multiplication. Suppose we have 8-bit word. So the highest degree is 7. In the term of polynomial, the highest term will be x to the power 7. Highest degree equal to 7. So in the addition, suppose my term is x to the power 5. Now we are adding x to the power 5, x to the power 5, 3 times. So what will be my answer? My answer will be 3x to the power 5, right? So in the addition operation, my answer can't exceed above the highest degree. Okay. So in the addition operation, answer can't exceed the highest degree. That is x to the power 7. But what about the multiplication? If we multiply x to the power 5, x to the power 5, x to the power 5 3 times, then in the multiplication powers are added up. So x to the power, that case, my x to the exceeding above the highest degree. So what is the highest degree? That is 7, and the highest, now I'm getting x to the power. So that is the problem over there. Exceeded highest degree. So what will be the solution in that case? In the residual environment, you can only apply the mod operation and will be your answer. But what about the polynomials? In the polynomials, you have to perform the mod operation also. Means in order to cope up this thing, you have to perform the mod operation over the multiplication between the polynomial values. But how can we decide the modulo term? Who will be decide? So actually this modulo polynomials is called the irreducible polynomials. These are already fixed. So in the question it will be given to you that this one will be used as a irreducible polynomials. So these modulo polynomials are called irreducible polynomial. So here there is one example. So these are certain irreducible polynomials such that you can perform the mod operation if you are associated with a certain degree. So if you are associated with degree 1, you can use this one as a irreducible polynomial, and if you are associated with degree 5, then you can use this one as a irreducible polynomial. So this one will be given in your question. So now the question is, perform addition x to the power 5 x squared plus x3 plus x squared plus 1 in Galois field 2 to the power 8 means highest degree will be 7. Okay, so this will be termed as P1, this will be termed as P2, and this operation will be understood as a XOR 1. And you have to perform the addition between these two polynomials P1 and P2. So there are two methods I will discuss one by one. So the first thing is, because the highest degree is 7, so just write all the terms x to the power 7, x to the power 6, 5, 4, 3, 2, 1 and 0. Again, write the same terms. Now select those one that have presence over the polynomial P1 and P2 and give the association with corresponding coefficient. So it is P1 now and it is P2. So what are the terms present in P1? That is x to the power 5. So 1 will be associated with x to the power 5 for x2, 1 and for x. And what about the P2? x3 is present, so 1 over there. x2 is present and 1 is present, so this over there. Now the remaining one will be associated with coefficient 0. Now perform the XOR operation. So for the XOR operation, 0 and 0 will be cancelled. Okay, the common one will be cancelled. So these are the common one now. So it will be cancelled directly. It will be cancelled. x4 is cancelled and x2 is also cancelled. Now these are the terms which are uncommon. So 1 and 0, what will be the answer? 1. So 1 into x to the power 5 plus 0 and 1, the answer is 1. So x to the power 3, 1 and 0, 1, x to the power 1 and 1 x to the power 0. So my final answer will be x to the power 5 x cubed x plus 1. Now what will be the shortcut method? The shortcut method says you have to select the uncommon term and cancel the common ones. Between P1 and P2, you have to select the uncommon terms. So what are the uncommon? Find out the x5 is present in the P2 or not. No, it is not present. So in the answer, directly the x5 will be put it over the first value. Now identify x2 is present in the polynomial p2 or not. Yes, it is present, so it will not consider. Now x is present or not? No, x is not present. So you can put x as an answer. Now x3 is present or not? Because all the terms in the p1 are over now, so you have to jump over the p2 and identify the same values in the p1 also. So x3 is present over p1 or not? No, so x3 can be the answer. X2 is present, so I will not consider x2. What about the 1? 1 is not present in p1, so it is uncommon term, so you can use x5, x3 and x plus 1 as an answer. Means in the shortcut, the answer will be uncommon term. Now what about the multiplication one? Multiplication is also very simple. So perform multiplication of p1, that is x to the power 5, x squared and x, multiplication sign, and x to the power 7, x to the power 4, x cubed plus x squared plus x. In GF, 2 to the power 8 means highest degree is 7. So because there is a highest degree 7, and after the multiplication operation there may be the values exceeded over the highest degree, because 5 plus 7 equal to 10, right? So we needed irreducible polynomial. So it is given to you in the question with irreducible polynomial x to the power 8, x to the power 4, x cube, x plus 1. So for the multiplication operation, you have to perform the distribution law. So distribute that these two terms. This is identified as P1 and this is P2. So x5 should be multiplied by the term of P2, because we have followed the distributive law. So x square will be separately multiplied by all the term of P2 plus x, x7, x4, x3, x square and plus x. Right? So just perform the multiplication. और कोई रास्ता नहीं है, multiplication करना ही पड़ेगा. So x to the power 12, x to the power 9, 8, 7 and 6. So I'm underlining this such that if I made a mistake, then I can identify it easily. So 9, 6, x to the power 5, x to the power 4 and x3. So this is the second term. Another one is x to the power 8, 5, x4, x3 and x squared. Now because these are the addition operations now, so we have to cancel out the common terms, because 1 and 1 equal to 0 in the XOR, right? So what are the common terms? That is x9 is present or not? Yes, x9 is present over the second term, so we have to cancel out. Now x8 is present, yes, so x8 is also cancelled. What about x7? What is that? x9, x6, x3 and it is x4. Why I'm writing this one? Yeah, so x7 is not repeated. What about x6? X6 is cancelled. x5 is present, x4 is also present. So what are the remaining terms? Remaining terms are x to the power 12, x to the power 7, and yes, x3 is also present, so x3 will be cancelled, and x square. But this is not your final answer, because after multiplying this with the polynomial p1 and p2, what is the highest degree? Highest degree is 7, but you will get 12. That is exceeding over your limit. Means you have to perform the modulus operation with irreducible polynomial that is given to you in the question. That one. So x8, x4, x3, x plus 1. So how do we perform the modulus operation between the two polynomials? The answer is very simple. You have to perform the division. ठीक है, जो आपका क्या बोलते हैं देसी वे है डिवीजन करने का, वही आपको दोबारा करना है. So x8, x4, x3 plus x plus 1. So it will be x4, yeah, x8, what I am doing, x12, x8, x7, x5, and x4. So identify the common term and cancel out. So x12 will be cancelled with x12, x7 also will be cancelled. So what are the remaining ones? The remaining ones are x12, x5, x4, and plus x square. Now plus 1, so 1 will be x to the power 8, x4, x cube, x plus 1. Cancel the common terms. So the answer will be x5, x3, x square plus x plus 1. So that will be your answer after multiplying the two polynomials. Okay. So that is all about the today's lecture. If you have any doubt, you can ask me. Otherwise, you can leave the meeting.